Hello everyone, welcome back. So till now what we have seen about what is a programming language, introduction to programming language, right? We also saw why Python is necessary. Then we talked about data type. Then we also talked about what are static and dynamic typing. Then what is a dynamic binding, what is a variable, right? What is an interpreted programming language, what is a compiler programming language, right? Now in this lecture we are going to look after what is operator, what is the concept of mutability, and everything in detail. So before we move ahead, let's start and just summarize whatever we have studied till now. So recap, right? So we are going to write recap, right? So till now what we have seen. So we started with introduction to programming, introduction, right? And then also we saw why Python is so important for data science. So we also saw this. We also saw IDEs, different IDEs. Then we moved ahead to know different data type, right? What is a sequential data type? Let's say list, string, tuples. Numeric data type, we have integer, float, complex. As of now we have discussed about the basic data type, that is integer, float, and complex number. Moving forward we will be studying advanced data types like string, list, tuple in a data structure lecture, right? Also we talked about variables in detail, right? We talked about what is static and dynamic typing, how it is different from other programming language. Then we also discussed about what is dynamic binding, right? What is dynamic binding, right? And one more topic that was very important that we discussed was what is a interpreted and compiled programming language. If you understand everything till now, whatever I have written here, it's okay, then you can move ahead with this video. If not, please go ahead and watch the last video, right? Also we had discussed some interview questions, what could be the possible interview questions. So for example, what is the difference between interpreted programming language and compiled programming language, right? What is a dynamic binding, what is a static and dynamic binding? So all of the interview questions already we have discussed in the last class, interview questions, right? So interview questions of the last class would be static and dynamic typing. We also have discussed about what is dynamic binding, right? Difference between interpreted and compiled programming language. Difference between interpreted and compiled programming language. And if you remember, I had also given you extra mile question, right? The question was, which is faster, right? Interpreted programming language or compiled programming language? Which is faster, right? The idea was to raise curiosity among you, that so that you can just go ahead and Google it out. So which is faster, interpreted or compiled? So the answer is compiled. Why? Just try to figure it out. I am not going to answer. If I answer, then you are not going to do some basic research, right? So this was things that we have done till now. Now in this lecture, what we are going to look at, agenda of this lecture, right? So in the last lecture we had seen the variables, right? So we will start in this lecture by knowing what are comments, right? How to write comments in the Python. So we'll start with this first, right? Comments, how to write comments in a Python variable. Then we are going to, in a Python programming language. Then we are going to see typecasting, right? How to convert one data type into another data type, right? And its type. Then we are going to see the concept of mutability in Python. and then finally we are going to look at operators, right? All of these topics, it's not that it is some advanced topic. Again, it is Python fundamentals. It comes in the Python fundamentals only. And after once we are done, again we will discuss what are some interview questions for this lecture that can be asked in the interview, right? Interview questions. So let's start, guys, understanding all of these topics, right? So I'll switch to notebook. So here is my notebook. So let's start. So if you guys remember, we had discussed about how to declare a variable. So let's say here a is equals to, let's say a is equals to 1. So this is your variable, a is 1. Very good. So this is your integer. Have you ever thought, right, how much long, let's say, how much large value of integer a Python can store? Can store, right? Have you ever thought about this, right? So basically a Python can store very large value. That is something, let's say a is equals to 1, E10. What is the meaning of E10, right? So E10 means simply, so let's say if I have to write, this means, right? So this means, just a second. So let's say 1 E10, right? It simply means 1 multiplied by 10 to power 10. That's it. This is the understanding of 1 E10. Now let's try to actually look at the value. So here, let's say we have a. So let's say here, this is the value, right? But how long or how large Python can store the value? So let's say here, if you just write a is equals to AE, right? AE 309. I guess this should be the largest value. So, okay, I'm just writing AU. I don't know why I written A. So 1E 309. So this is infinity, right? Before that, if you see 308, then you will realize that this will give you some value. So this is some value that has been given. But the moment you write 1E 309, it means it will give you infinity. Obviously, you will never go to this till this largest value, but this is the maximum amount of integer that Python can calculate. Similarly, in float, so it will be like, let's say 1.9 or 7, whatever it is. So let's say 1.9 E309. So this is also 309 only. Okay, infinity, right? So let's say 8, right? Okay, it is still infinity. So maybe 7, right? So you have to do it. Yes. So this is the largest value. So largest float value, right? Largest float value. This is largest integer value, right? Obviously, we understood that. Now, this, whenever I had written a is equals to 6, it means a is a variable where 6 is the value, right? This was the understanding. But can we declare variable in some other way as well? The answer is yes. How? So one way was to declare the variable, something like this. But you can also declare variable in other ways. So different way of declaring the variables. How? Right. Very easy. A is equals to B is equals to C. A is equals to B is equals to C. Right. And if you just execute, let's say this is a value 10. So A equals to B equals to C equals to 10. It simply means that all the values of this variable, right? Values of all of these variables. So let's say A, it will be 10. B, it will be 10, right? C, it will be 10. This is the understanding, right? So now let's say if you define variable something like this, A equals to 61, right? B is equals to 62, right? B is equals to 65, let's say. C is equals to 67. Now this is the way you have defined 3 variables, A, B, C, right? Now this is just the standard way of defining variable, but you can also define the variable something like this. A, B, C is equals to 61, 65 and 67, right? So now if you see again, A61, B65, C67. So the whole idea is whenever you are defining a variable, these are some cool approaches to define a variable, but you don't need to worry about that, right? If you see that this is the way the variable is defined, you understand that, okay, this has been defined in this way. It means A is 10, B is 10, C is 10. Or if it has been defined something like this, then you understand that A is 61, B is 65, C is 67, and nothing else. Now guys, this was whatever we had studied till now about the variables to some extent, to just revisit the concept. Now guys, if you're writing something in Python, right, you can also treat any line here on Jupyter Notebook as a comment, right? What is the meaning of this? So let's say you have written A is equals to 10, and if you execute, this is treated as a code, right? It is actually interpreted by the Python. What is the meaning of this? What is the understanding? But let's say if you want to write something in a plain English language, right, where you don't want actually Python to execute something, that is your comment, right? And how do you write comment? Already you might have seen, see, this is the way I have written a comment. This is not being treated as a code for this cell, right? So for example, let's say here, how to write comments? Thus this is the way. So let's say this is a lecture in Python. So if you execute, right, Python, right, it will not make any difference because these are comment. It will not be treated as a code, right. So now let's say you can have different line of comments. So this is first line of comment, right? This is second line of comment, this is second line of comment. Whatever number of comments you want, you can just put it. Right. But why it is necessary? Why commenting? Why comments? Right. This is very important, guys. So what happens in industry, right? Whenever you work in a big project, let's say whenever you work in a big project, right? Person A is working in some part, person B is working in another part, person C is working in another part. So person A has written this part of code, person B has written this part of code, and person C has written this part of code. Fine, right? They have written. But let's say someday person C is on leave. He has gone to meet his girlfriend Monjolika, right? Now there is some requirement and person A has to edit the code. Person A has to edit the code of person C. Then if person C has not provided relevant code, then he will not be able to understand the code successfully. It will take time for person A to understand this particular piece of code that is written by person C. If you want an analogy, I will just give you. So let's say there is a kitchen. There are multiple cooks, C1, C2, C3, right? C1, C2, C3 making a dish. Let's say dish. This is some dish. Now imagine that cook 1, cook 2, cook 3 doesn't interact. Then what will happen? Cook 1 comes, do something with the dish and also add a pinch of salt. Now cook 2 comes, he is not interacting with cook 1. There is nothing written, any notes that pinch of salt has been added. Then C2 will also add another pinch of salt. Similarly, C3 will also add another pinch of salt. Now what will happen? Instead of creating a dish, it will be a mess, right? This will not be a dish, right? Even if you want to see another analogy, if you have been hospitalized, right, or if you have been to hospital, you might have observed this, that whenever there is a patient, there is some notes attached to the bed of a patient, right? where whenever some nurse comes, given a medicine, right, he or she will note down, okay, this given, morning breakfast done, right? And this is the way you keep track what is going with that particular patient, right? Similarly, if you want to keep track of the code, you should always provide comments. And as a developer, this is the best practice, that you should always and always write comments. This is the industry use case. Very important to do this. Why comment? Right. Similar to patient health tracked through notes by different nurses, right? Or let's say similar to patients, or similar to multiple cooks. Let's say multiple cooks, right? Destroying the important dish by adding multiple times salt, multiple times, right? You don't want to mess up with your code, right? Similarly here, you want to keep track of your code, you want to keep explainability of the code, explainability of the code. So basically, if you just write some small comments, then this is going to help other developer save their time and better their understanding, right? So a software can also be messed without comments. So this is the understanding, right? Now how to comment, you already know this hash. Just keep a hash, it will be commented. But let's say there are 3-4 lines. Let's say print 1, right? Then again print 2, right? Now if you want to comment all of these lines together, how can you do this? Right? This was your single line comment. This has one single line comment. Again you put has another single line comment. But let's say you want to comment these 3 lines together. Then how can you do that? Right? Easily this can be done. How? Just select this, then press Control plus /. Done. See, this is commented. Control plus this again it is uncommented. This commented, uncommented, commented, uncommented. Very easy, right? So you can just write here control plus /, comments multiple line in one go, and vice versa, and uncomments as well, and uncomments as well. But is there any formal way of writing multiple line of comments? The answer is yes. Right? How? It is called as doc string or document string, whatever you wish to say, doc string. So for example, this is a multi-line comment. This is initiative by CareerCraft for affordable data science courses. Now, if you have to comment this, very simple. Either single quote, do like this, and let's say do like this. Done. Now, if you just write a is equals to 5, a equals to 5 will be executed, but this will be treated as a comment. Not only this, you can also use double quote. Right? It was single quote. Right? If you see, this was single quote. Right? You can also replace this with double quote. Still, it will be a comment. So let's see it. So here, if you just write it here, double quote like this, 3 double quotes, and then again 3 double quotes here, right? A, then this will be your comment, and this will be your code. That's the understanding. This will be again used, right? Again used in function, how to write the best practices, how to write function, how to write a class, right? Again we will be seeing this docstring again, right? But it is widely used, right? Widely used, right? In the industry, so that, right, so that the code is not a mess and it is understandable by fellow developers, right? So initiative, so I will just write change initiative, initiative. So sometimes guys, my spelling might be wrong, so here let's say affordable, right? Because I just type and writing, I'm typing and writing. Now very good, we have understood till here. Now let's say 3 plus 2, 3 plus 2, if you just do, it is 5, right? So now the moment you do like this, 5 plus 2 plus 2, right? Then what it will happen, right? Just pause this screen and try to think what will happen in this case. If you do so, it will throw an error. Why? Because we know that this is integer, but here in this case, this is an integer. Inside string, this is an integer, but due to this particular to code, this has become a string. So you already know how to define a string. So let's say this is a string. This is a string. Just write type of this. This is a string, right? If you just write like this, type of like this 5. So again, this is a string, and you cannot add a string with a integer, something like that. So now what we have to do? We have to convert the data type. So here comes the next concept, data type conversion. Right? Conversion. This is also called as typecasting. Right? Typecasting. What is the meaning of this? Right? So let's say here data type conversion. So you already know, let's say here it is 5, string. But inside this it is an integer. So you can convert this to integer. Right? So data type was string. Now data type is integer. Since you are converting the data type, this is called as typecasting. Typecasting. You are casting a data type to another data type. That's it. This is your typecasting. Now typecasting is of two types, right? First one is implicit. Right? First one is implicit. Right? And second one is explicit. What is this implicit and explicit? Right? This implicit means Python takes care of the data type, conversion, or data type typecasting, Right? How? I will give you an example. And here explicit means externally you need to change the data type. I will give you example. So for example, let's say here implicit data type casting, implicit. So here let's say in this case, if I do 3 plus 3.5, now what will happen? Right? So one is integer, let's say integer. Another one is float, right? Plus float. Right? Python will understand that this is also number, this is also number, but this is integer, this is float. So result should be float. So Python will change the data type implicitly. This is the understanding. Execute it. See here, 3 plus 3.5, it is 6.5. That is the understanding. Now comes explicit typecasting. What is the meaning of explicit typecasting? So let's say here 3 plus 2.1, right? Inside a string, right? You cannot do this. Inside a double quote, you cannot do this. So you have to explicitly convert this. How to convert this? Just write whatever data type you want, int. The moment you write int, it will be converted to integer and then it will be added. But here in this case, since 2.1 is there, it is a float, we will write float, right? Not integer. Why? I will show you. So the moment you write now, see 5.1, right? So if you want to convert something to a float, just write float before that. So let's say 3.1, right? Done. This will be your float, right? Now let's say if you want to convert integer, so let's say again double quote, and here we have 3. So this is your integer, right? Now let's say there is some string value inside them, some string value, there is some float 3.4. Can you convert this to integer? What do you think? Will you be able to do this? Please pause the screen and try to do this, right? The moment you do, it will throw you an error, right? See, it will throw an error. Why? Because if you convert this float to integer, right, and if it is converted, there will be a loss of information, because 3, it will give you 3, but 0.4, where will 0.4 go, right? So it will throw an error. So it throws the error. So error because information loss will happen. This is the understanding, right? This is the understanding. Now let's say if again another string is there, 3 plus 5j, right? Now if you want to convert this to complex, just do complex. See how beautifully it will be converted to complex. See, but the moment you will try to do integer, again the same thing you cannot do, because it will be having a information loss. See, right? It will throw an error, right? So what is the meaning of typecasting? Again, if you have to define this, typecasting. So typecasting simply means, cast means to change the data type. Cast means to change the data type. This is the understanding, right? Can we similarly convert a boolean value? The answer to your question is yes. So let's see that as well. So for example, let's say if you have, before understanding that, how to convert to a boolean value, right? First of all, understand one thing, that true and false are boolean value, and true is stored as 1 in Python, right? And false as 0, right? False as 0. Now let's try to look at this. So for example, let's say if you have true minus true. So if you do, it means 1 minus 1, it should give you 0. See, this is the proof, right? If you do true minus false, then it will be 1. Now if you want to convert 1 to true, how can you do that? Just write boolean of 1 and this will be converted to true. Then again, if you want to convert boolean of 0 to false, just write like this, right? Now if any string value is there, right, then just write bool of, let's say any string value. If any string value is there, it will be converted to true. See, but if there is nothing, that is none data type, bool of none, right, this will give you false, right? So this is the way you convert the data type in true false as well in the boolean. Actually I had to cover this in the previous lecture, in the last lecture itself, but I converted I captured, or I covered here in this lecture, right? In the last lecture I missed it covering, but yes, now I have covered. So this is the understanding. Now one more thing here that is important to some extent, that Python is a case sensitive programming language. Python is a case sensitive programming language. Python is a case sensitive programming language. What is the meaning of this? Case sensitive programming language. What is the meaning of this? Right. So let's say a is equals to 6. Now if you want to access this a by small a, then it is not correct, right? So execute this. Obviously A we have stored above some other value, but let's say here maybe j. It is not possible that it will be accessed by small j. It will give you name j is not defined. Capital J means capital J. That's it, right? Now if you access, it will be accessed. So Python is a case sensitive programming language, right? Now one more thing. So let's say whenever you do print. So what is a print? Print is an inbuilt function we have discussed in the last lecture. So here if you write 234, then 234 is printed, right? But have you ever thought that okay, 234 is printed, what are the other way to print? So for example, let's say A is equals to 2 and B is equals to 3, right? Now if you write print A, right? Print A, right? And then just write print B, right? Why it is so that first A is printed and then in the new line B is printed, right? So if you just execute, see 2 and 3, right? If you want to print something like this, print A and B, something like this, then what will happen? There will be a space between these two variables. So just write like this, see 2, 3. So what is happening here? So by default, right? By default, right? There is a space, here, a space here, right? There is a space, right? Here, right? All the print statement will be in a new line. All the print statement will be in a new line. So that's the understanding, right? So that's the understanding, right? Now how to know this? So basically just write the name of the function, so print, and then hit shift and tab inside that. Then you will see a lot of detail. See, this is docstring that we had seen just few seconds before. What is a docstring, right? So docstring prints the values to a stream or to say something like that. So here if you see separator and AND, right? This two parameter, this is called as parameter, right? Is very, very important. It simply means AND. AND means this backward slash AND is a new line. We will be discussing this again in the string chapter, but this backward slash AND means a new line, and separator means by default everything will be printed with a space in between them, right? So this is the understanding. So for example, again, let's say A and B. So A and B, by default there will be space, but the moment you write separator is equals to some hash, right? Like this. See 2 has 3, right? You can also write anything as a separator character, right? So here you can write anything, this as a separator. See here, this. You can also write something like this, plus. See, this is a separator character, right? So this is the understanding, right? This is the understanding. Now guys, moving ahead, right? Till now, whatever we have seen, right? We have actually, right, defined the variable on our own, right? But can we define or can we take input from the user? To answer your question, yes, we can also take input from the user. Take input from the user. Input from the user. How? How can you take the input from user? Right. For that, you have to use a Python keyword, that is input. Right. Just use input, and then maybe let's say you can just write enter a number. Enter a number. Right. So what happens these days? Many of the program is an interactive program, right? You would love to take any input from a user. That's why here A is equals to input, enter a number. So for example, so let's say here again B is equals to input, enter a number, enter a number, enter a number, input, enter a number. Let's say enter a number. Now what you can do? Let's say you want to print it. What you want to print? Print A plus B. A plus B. Now let's execute this. Let's say enter a number. What is the number? 10. Very good. Again enter a number. 15. Very good. Oops, it should be 10 plus 15, 25. But why it is giving 1015? Right. So what happens? By default, input takes everything as a string. Now you must be thinking, why? Right? Why? Very simple reason. It is taking everything as a string because you can convert a string to integer, but you cannot, right? So for example, I will show you. So let's say here, if this is 2, right? You can convert this to integer, int. If inside the string there is a string integer value, you can convert this, right? It is easily doable. But let's say if there is a string here, AJAY, you want to convert this to integer, will you be able to do so? The answer is no, right? So by default, input takes everything as a string. Why? Because string is universal data type. That's it. This is the reason, right? String is a universal data type. So by default, it takes a string. So now how to add? Just convert the input that you have taken. So whatever you have taken, so let's say here. So let's say here, you want to convert this, just convert this like this, integer, right? Integer, and then again, integer, something like that, right? Done. Now if you just print, see here, let's say 17, 3, and it should give you 20. This is the understand, right? We will be seeing multiple application of this particular, input at a later stage. Now one more thing. So let's say here you write a is equals to 3. So what is this a? This is variable, right? What is this? Operator that we are going to, see in the second part of this lecture. Only here in this lecture itself, we will be looking at operator, and this is called as literals or values, right? Literals or values. So this is your variable, this is operator, this is called as literals or values. This variable is also called as object. You can consider this as an object as well. Now, what is the understanding of this, right? What is a different type of literals? Already you have seen some type of literals that, if you remember integer, float, what were those? Those were actually a type of literal, right? So those were also the example of literal. Now, to understand literal in detail, and also we have seen the scientific method. So we have also seen the scientific method of literals, right? Now, so I will just, start with the same example. Let's say a is equals to some value. Let's say a is equals to 3. So here a is equals to 3. Then I will just write a is variable slash identifier, right? So that we already have discussed in detail. Then 3 is literal slash values. Already we have seen the type of literals, but again we will recap those things. And then finally equals to is operator that we are going to look at in the next part of this lecture itself. But now again, literal values. So what are different type of literals or values? So there are different kinds of literals. So I'll just write different kind of literals. Majority of them already we have seen it, right? First one, integer, right? Integer, again this integer is of multiple types. Let's say binary, right? Decimal, octal. You don't need to remember anything, right? Or hexadecimal, right? Then again we have for float. So float, we also have float. So here in this float we have float number, right? Scientific number. So let's say float number, right? Then scientific number for both big and small, big number and small number. Already we have seen the big number, but small number also we will be seeing. And complex, complex. Already we have seen the complex as well. So let's try to look after one by one. So let's say for A is equals to, let's say here I will just write 0 B 1 0. So what is this B? B represents binary number. We will be seeing this in operator again in detail. So this is your binary representation of the number. So if you just write this, then you will realize 2. So this number is nothing but 2. Right? Decimal, you already have seen, B is equals to, let's say, 100.1. So this is a decimal representation of number. If you want to look at the octal, then again 0O, just write 0O 300. So this is octal representation of number, octal. So here I will just write C is equals to this, and if you just execute, this is 192. Right? Hexadecimal, so let's say here again 0x, let's say 1 to C. Right? So this is your hexadecimal, right? Decimal. Right? Execute this is 300. Right? Scientific notation, already we have seen 2E, right? 2E, let's say maybe 10, right? So scientific notation of a big number, scientific notation of a big number, What is the meaning of this? So whenever you are writing 2E10, right? 2E10, so 2E10, it simply means 2 into 10 to power 10. That's it, right? So this is your big notation, scientific notation of a big number, right? Now similarly, right, let's say scientific notation of a small number, how can you write? So here in this case, instead of 2E10, just write 2E minus 3. Just do this, or 2E minus 10, that's it. See, okay, here I will just write minus 3 so that you can relate it. See here. So this means 10 to power minus 3. So this is 2 into 10 to power minus 3. 10 to power minus 3 simply means 2 to power 10 to power 2 by 10 to power 3. And that's why you see 3 decimal places and a decimal. So that is the understanding. So what we have seen till now, guys, till now, if I have to write it again, so let's say till now what we have seen, right? So till now, right? Till now. So one segment is over actually till now, right? We have saw different way of declaring the variable, way of declaring a variable, right? We also saw typecasting. We also saw user input, how to take user input, and then we also saw different types of literals, including scientific method. Now the major topic that we are going to look at is operators. This is going to be very interesting. What is operator, right? Why do we study operator? Because this is very important with respect to understanding Python programming language, right? So what is an operator? We are going to discuss everything in detail, right? So, but before operators also, I guess we have skipped one topic, that is mutability, the concept of mutability. Then we will move ahead to operators, right? So yes, this video is going to be very long, but yeah, we are going to understand everything in detail so that you guys don't need to refer to any resource after this particular lecture. So what is the concept of mutability, right? Right? What is mutability? I will discuss this in detail, right? So object whose state cannot be, or in this case, whose state can be changed, that is called as mutable. So they are called, right, can be changed after they are created. So these are called as mutable object, or mutable data type or data structure also. So mutable object, right? What is the meaning of this mutable object? What is the understanding? So let's try to look after this. So for this, we'll go to again notebook, right? So I'll just write it here, mutability, concept of mutability, right? What is the meaning of this? So let's say we have a is equals to 3, right? So let's say this is your a, fine. Now, whenever you are writing a is equals to 3, what is happening? So basically, let's say this is your processor, right, or RAM, right? In your RAM, let's say here you are having a value 3 and this is identified as A. Exactly, it doesn't happen this way, but assume that this is the way it is happening. We will be seeing how exactly it happens in the data structure, right? But assume whenever you say A equals to 3, right, a variable, a memory block is created. This is your memory block. A memory block is created where the value is stored as 3 and this is identified as A. Very simple. Now, if you write B equals to Ajay, what will happen then? Right. So again, in your RAM, a memory block will be created and it will be stored like this: A, J, A and Y. This will be identified as 0, 1, 2, 3 and everything will be identified as a B. So B0 is A, B1 is J, B2 is A, B3 is Y. So this is called as indexes, right? We will be looking at this index again, right, in data structure. As of now, you don't need to worry about that, right? So what is a variable? Variable is a container where data is stored. How data is stored? This is stored in this way. This is the understanding, right? So now let's say you have understood this. Let's say let's write A is equals to Ajay. Let's write A is equals to Ajay. Now if you want to access, or let's say if you want to access small a, what you will do? A2. That's it. So this is your A. Right. This is called as positive indexes. There is something also called as negative indexing. You don't need to worry about this as of now. We'll be talking about this in data structure. Just you need to understand here that if you want to access A small a, then you can just do A2. A is the name of variable and 2 is the name of index. If you want to access Y, so A3. Just do it. So Y. This is the understanding. Now, one of the data type, that is sequential data type that we discussed, right, is list. Right? I mentioned this. We will be discussing this again in detail in the upcoming lectures. But let's say there is another container that is called as list. Another container that stores the data. So another container that stores the data. What is a list? All detail about list we are going to see in the upcoming lectures. But let's say this is a list container. This is a list container and the values are, let's say 1, let's say Ajay, right, Ajay, and let's say Bangan, let's say tomato, right, tomato. This is your 3.5, right, 3 or 2.3, something like that. So this is your list container. Now again, what will happen? This is again a data structure, right? Again, you can just write it here. So let's say how it will be stored. Again, you will be something like this. You will be having something like this. So one memory block here will be 1, then another it will be Ajay, and then again Bangan, right? Then again tomato, and then again 2.3, right? So now this will be named as, let's say, list container, right? And if you want to access 0th 1, 2, 3, 4, done. That's it. And I will just show you. So if you want to access, let's say Bangan, right? How can you access the Bangan? Just write 2 and you will get Bangan. See, Bangan. This is the understanding. Now comes the interesting thing. We have understood this, how to access the element of a list. So list is another container. We will be seeing this in detail in the upcoming lectures. Now there is a concept called mutability. What is the concept of mutability? Right. What is the concept of mutability? Very easy. So I'll note it down. Mutability. What is the concept of mutability? Objects slash container whose state or value can be changed after they are created, right, are called mutable objects. This is your mutability concept, right? This is your mutability concept. Now let's say here we have B is equals to right Ajay. Again let's say B equals to Ajay, right? Now here let's say I will access, right, let's say maybe J. So if I write B1, that is J. Now let's say if I want to change this J with some value, let's say I, right? Try doing it. So I want this J, instead of J, I want I. Can you do this? Right. Try it. Pause the screen, try to execute this particular piece of code. If you execute this, you will find it will give you an error. So strings are immutable. Mutable means where you can change. Immutable means you cannot change. Simple. Right. But when it comes to list, it can be changed. So if I want to say, let's say here it is a list container 2. So let's say list container 2 is Bangan. So instead of Bangan, now let's say, so this is your Bangan. If you want to have Alu, just write Alu here. Alu. So if you see here, now execute list container again, right? Then you will realize Bangan has been converted to Alu. See, one Ajay and now Alu. This is your mutable type of object and string is your immutable type of a object, right? So let's summarize the discussion, whatever we have seen, right? So let's summarize the discussion here. So let's see here we have understood mutability, concept of mutability. So let's say mutable, immutable, right. So here in this case you can just write whose state can be modified, whose state cannot be modified. Right. Example here in this case, list, dictionary, right. Dictionary. We are going to look at this again in detail, right, about all of these data types. Here string already we have seen, integer, right, float and so on, right. But now you must be wondering why it is important to understand the concept of mutability with respect to industry, how you are going to use this in the industry. So like there is a reason behind it, why it is important. So let's say there is a flow of code, right? Which stores the name after each of the stages or each of the step. So step 1, right? This A is, let's say, name, right? Let's say Ram, right? Step 2. So step after 1 is step 1, there is step 2, and then let's say A is equals to name, right? Then we are having Ram, and then we will be having, let's say, Syam, right? Similarly, let's say step 3, right? A is equals to again name, right? and then this time Ram, Syam, and let's say Mohan, right? So at each step, right, this particular object or variable is changing, and that's why you need that type of data or that data type which actually is mutable, which you can modify after it is created, and that's why the concept of mutability is important. Further use cases we will be looking at whenever we will start with data structure, but this is the understanding. So what is the use case? Use case of mutability. Mutability in the flow of code, many times you need to modify a variable or object, modify a object, then you need a mutable data structure. That's the understanding. So now we have covered the concept of mutability, and now let's move ahead with the last and the most important topic of this lecture, that is operators. So what are operators? We are going to discuss everything. So operators. So we are going to look at operators, and again, as usual, we are going to look at in depth so that you don't need to worry about other things, you don't need to refer to other resources. So Python operators, right? So why do we need Python operators, right? Already you have seen one of the operator, that is equals to, but why do we need? Because you want to do some operations in Python. So whenever you do operations in Python, right? So what do you want to do? You want to do some computation. If you are learning machine learning, then what you are doing? You are trying to learn some mathematical relationship. If you want to learn some mathematical relationship, you might be doing some mathematical computation. But how you do mathematical computation? Using operators, right? And there are multiple types of operators, right? So let's start looking at different type of operators. The first one would be arithmetic operators. Second one would be comparison operators. Third one would be logical operators, right? Fourth one would be bitwise operators, right? Another one would be assignment operator. Then we have membership operator. And then we have identity operator, right? So you must be wondering, Ajay, there are a lot of operators, right? But no need to remember anything, right? And in fact, this bitwise operator, as a data scientist, you will rarely use. This is used in some embedded, right, programming and like that sort of thing. If you are coming from a semiconductor industry, then you might be using that, right, more frequently. We just use limited bitwise operator. But again, moving ahead with each of these operator, first we need to understand the definition of operator. What is operator, right? What is an operator, right? So to define it, special keywords / symbols that are used to perform right, operations on values or variables. or variables. That's the understanding. That is your operator. Right. Now let's try to look at this example. Once we will be starting looking at each of this example, then we will be also looking at the use cases. So no need to worry about that. We are going to look at each of the use cases, right, one by one. So let's start. So here, let's start with the operators, right? So let's start with operators, right? So if I have to, again, I have already written the definition of operators. So, but still, so that everything is in notebook, operators, operators, special keywords, special keywords, special keywords, keywords used to perform operations, operations. That's the understanding. But why do we need it? To manipulate the data, to do or to compute / manipulate the data, manipulate, to do some calculation, manipulate the data. We need operators. So first let's start with arithmetic operator. Arithmetic operator. What is this arithmetic operator? Very easy. So let's say A is equals to 5, right? B is equals to 6 or 76, let's say. So A plus B. What is this? 81. This is your arithmetic operator. This is your addition, right? Again, let's say 20 minus 4. What will this? This is your subtraction, right? If you want to divide 20, let's say, right? If you want to divide, so 20 divided by 4, it is your division operator, right? Something is called as modulus operator, modulus. So it will give you remainder. So let's say 19, 10, let's say 10 modulo 3. This is your remainder, right? If you want to do the power, so what you can do? 2 to power 3 if you want, 2 to power 3. Just write asterisk, asterisk. Asterisk, asterisk means 2 to power 3. It means 2 into 2 into 2. See here, it will be 8, right? Right. Now, if you want to do some floor operator, so let's say 12 divided by 4. So this is called as floor operator or integer division operator. Integer division / or floor operator, floor operator. So this will divide and not give the value in decimal. It will just give you the quotient, right? So 4 3 is 12. That's how you got 3. So let's say here 13. 13 is there. See here only 3. It will not give you in decimal. So this is the first thing. Easy to understand, right? So what is the use case of arithmetic operator? So let's write it here. Use case, right? Use case, mathematical calculation. Use, right? Mathematical calculation. First thing. Done. These are some mathematical operator. Now let's come to comparison operator. What is comparison operator? Right. So here you compare the two values, right? So here comparison operator, comparison operator, operator. So here you can just write compare two values, right? Right. So once you compare the two values, it will return a boolean value, right? So for example, right? So let's say you write 2 is equals to 2, right? Yes, it is equals to, it means equality operator. It is equal, then it will give you true. See, if you write 2 is not equals to 2, right? This is inequality. So this will give you false because both are equal. So this should give you false, right? If 10 is greater than 2, right? True, right? 10 is greater than equals to 2, right? Then see, true, right? Right. Now let's say 10 is less than equals to 5, right? It will give you false because this is not true, right? So this is called as comparison operator, right? Right. This is the understanding. Now comes logical operator. So now let's say logical operator. But before going to logical operator, first let's try to understand what is the use case of comparison operator. Very simple, to compare objects, or variables, compare objects. That's it. This is the understanding. We are going to look at a lot of use cases of comparison operator in conditional statement in the next lecture. Lot of use cases in conditional statements. I will discuss this again, right? So for example, here in conditional statement, you can just write if weather is equals to rainy, right? Go and play, right? Print, go and play, something like this, go and play. So these will be the use cases that we are going to look at just after this lecture, maybe in the next video. Right. Now comes the logical operator. This is also going to be very, very interesting. So what is this logical operator? So to understand this logical operator, right, I don't know how many of you remember, but you might have studied in your high school days and or condition, logical operator. Right. You might have understood or you might be knowing and or condition. Right. So what happens in this condition? If you guys remember, this is your and this is your or, right? So true and true. This will be your true, right? True and false. This will be false, false and true. This will be false, false and false, right? Right. If I put in and everywhere, so and here as well, this is your again false. This is the understanding. And similarly for or, so true or true, this will be true, true or false, this will be true, false or true, true, false or false, that is false. This is the understanding, or you already know, and you already know true is 1 and false is 0. Right. Same thing can be written in the form of 1 and 1, 1 and 0, right? Again 0 and 1, right? And again here 0 and 0. And this you can also write this symbol. This is why this is your bitwise operator. And right, true is 1, false is 0, 0, 0. So just you replace true by 1 and false by 0. That's it. Right. Right. Because Python understands true as 1 and false as 0. This is the understanding. Now coming to the best part that we are going to look at. So here, but how will you remember this? Many of the time you might be forgetting this, right? You might forget this. How to remember this? So one way, if you are, very smart enough, then you will just say wherever all are true in and, this is true, otherwise false. And similarly, when both are false in or, then it is false, otherwise true. This is one way to remember. Otherwise, just remember a very simple analogy. So let's say if someone is going to get married, then what he or she will look, right? Let's say you are going to marry. You are going to marry. Going to marry. So obviously you want your partner to be both rich and beautiful / handsome. You want both of those things, right? So if both of those things is present, then only you will going to get married. Then only you will marry, right? Right. This is the understanding. Okay, here I guess I have by mistake. Okay, no, this is right. So here is the result. Right. So now, if let's say assume that is rich and here handsome. So if rich and handsome both are true, then only true. Otherwise, if he or she is not beautiful or handsome, you are not going to get married. If he or she is not rich, you are not going to get married. If not both, then also you are not going to get married. That's it. Done. And operator. And opposite of this is or. Simple. In or, you are a very good human. You are satisfying human. You don't care of anything. Right. 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 You say that even, right, one thing is present. Let's say if a person is just only rich, I am okay. If both rich and handsome are beautiful, that is also okay. And if the person is only handsome or beautiful, that is also okay. I will get married. Only I will not get married in one case, when the person has not both, neither rich nor beautiful / handsome. This is the way you can just remember, a small way to remember things. Now guys, moving ahead. So logical operator, let's try to look at this quickly. So true and true. So true and true, it is true. Then we have true and false, right? True and false. This will be your false. Then we have false and true, something like this, right? This will be your false. Then similarly here you can just write true or true. It will be true. Then we will be having true or false, false, right? So this will be true, then false or true, right? Then you will get something like this, true. Then let's say false or false. This is false. This is the understanding of this, right? Now moving ahead, so we have something also called as not operator, right? So this is related to logical itself, not operator, not operator. What is the meaning of this? Opposite of something. So not true is false, and not false, right? Not false is again true. That's the understanding. Now moving ahead guys, we have something called assignment operator. Assignment operator. Alright. Now what is this assignment operator? Right. So already we have seen this assignment operator, but before going ahead, so let's look at the use cases again here. So we have seen the logical operator, right? So multiple conditions, right? So having multiple conditions. How? So let's say if weather is equals to rainy and bat is there, bat present, then I will go to play cricket. So you can understand this way as well. So this is your logical operator. Now we are going to look at assignment operator. What is assignment operator? If you guys remember, you used to do a equals to 3, a is equals to 2. What is this equals to? This is your assignment operator. You are assigning the values. Now guys, one more thing. So let's say a is equals to 2, and then you just add a plus 4 and then reassign this to a, and then again in the last print a. The value is 6. But you both of these steps can be done in one line of code, right? There are 2 lines. You can do it in one line. How you can perform this 2 piece of line in one line? So you can simply write a plus equals to, right? So let's say here I will just write a equals to, right? So or here you can just write a is, okay, fine, let it be. So a is already 6, you know this value is already 6, a value is 6. Now you just write a plus equals to maybe 3. That's it. Now if you execute this, it will give you 9. How? So basically these 2 steps are clubbed here in one line. This is plus equals to. How it works, right? How it works? So Python code actually executes from left to right. We will be seeing the order of precedence. No need to worry about that. But what is the meaning of this? So a plus equals to 3, right? Very easy. So whatever value you have in a, that was, let's say 6. Earlier it was 6, right? So how it works? Left to right. So 6 plus. So here the value is 6. Now plus 6 plus 3. 6 plus 3. That becomes 9. And then we have equals to symbol. Then assign this 9 back to a. This is the understanding. I will repeat it again. So a plus equals to 3. Already you know a has value 6. So first comes plus symbol. So it will add plus 6 plus 3, that is 9. Now comes equals to operator. See, equals to operator. Then it will reassign back to a. And that's how this is the understanding. And not only addition, you can do multiplication as well. So let's say a is equals to 2, right? You can do the same thing here. A multiplied equals to, let's say, 3. Now see a, it is 6. You can do division as well, right? Equals to, let's say, 3. Now a, in one step, 6 divided by 3 is 2. That's how you got 3. Sorry, you got 2. That's the understanding, right? So this was assignment operator. So again, use cases, right? To assign the values in the data. To assign values to the data. That's the understanding. Now comes the membership operator. So this is also very, very useful, very important, and you will be seeing this a lot of many times. So what is this membership operator? So let's say here A is equals to CareerCraft. Now if you want to check if F is present in this CareerCraft or not, how can you do? Or C is present there or not. So just you check C in. Membership itself means if something is member of something, right? C in A. So if C is present in this variable A or not, see here, it will give you true. But let's say if you want to see Z present in A, it will give you false. See here, false. Another example, let's say study. If you want to check study in, here I study in data science, right? I study data science or something like this, science, right? Now since study is present, it will give you false. Sorry, this is small s, so you have to just write it small s. It will give you true, right? So this is your true. But if you would have written a capital S, since Python is a case sensitive, it will give you false. Right. See here, this is false, right? Any other name? Ajay. Let's say Ajay in, right? Ajay in, I study in data science. It will give you false. See, right? Now moving ahead to another operator, that is identity operator, right? So what is this identity operator? We will talk about this, but before this we have understood the membership operator. What is the use case? Value check. If you want to check any value is present in some other value or not, that you will be doing a lot of many number of times whenever you will be writing a lot of big code. That's where you will be looking or using these many number of times. Now comes identity operator. So what is identity operator? I will just write it here. Compare the memory reference. To compare the memory reference. Right. Now let's try to look at this. What is an identity operator? So for example, it is a very small thing. Let's say A is equals to, let's say 2, right? A is equals to 2 or 3. B is equals to, let's say 5. Now if you say A is B, right? Try to execute this. A is B. It will give you false, right? Why? Because the memory reference of A. What happens whenever you create a variable? As of now, whatever you have understood, whatever we have understood, whatever I have taught. So let's say this is your memory. So let's say here in this case, you will be having some value, let's say 3, and this will be referred by A. This is the understanding, right? Now B is equals to 5. So what will happen? This is 5 and this will be referred as B. Something like that. Obviously, this is not the correct way to understand. We will be looking at in the data structure, but this is the understanding, right? Now what will happen, right? So here both of the memory reference is different for A and B, because A and B is stored at two different memory location, and that's why it says you false. A is B false, and you can verify this also. Just write ID of A. So the moment you do ID of A, you will realize this is the value, and if you do ID of B, right, you will check, you will get this value. See, it is 76 and it is 40. It means both are different memory location. Right. Now let's see, A is equals to Ajay. So let's say if you have done A is equals to Ajay, right? And now let's say A is equals to B, or let's say B is equals to A. You are assigning the value of B is equals to A. Let's say you do this, and now you do A is B. What will happen? It simply means the understanding of this, you can understand this way in a very simple way, that let's say this is your memory location, and let's say here it was Ajay, right, and this was referred as A. Now the moment you do B is equals to A, B also refers to the same thing, and that's why now if you execute this, it should give you true. See, true, because A and B is referring to the same memory location, right. So I can just write A and B is referring to same memory location. That's the understanding, right? If opposite of this, if you want to write A is not B, then you will realize it is false, because actually it is referring to the same memory location, and if you write A is not B, obviously it will give you false. So this is the understanding. Now last operator, that is bitwise operator. Right? Now what is bitwise operator? So operations at bit level. So what is bit level, right? So we are going to understand this in detail, but as a data scientist, you rarely will use this, right? But let's try to understand this. So any number is there. Let's say if a number is there, right? So I'll just write it here. Bitwise representation. Right? Bitwise representation. Any number can be represented in a form of 1 and 0. So for example, let's say 2 is there, or 1 is there, 2 is there, 3 is there, 4 is there. How can we represent in binaries? Right, binary means, right, 1 and 0. So how can we represent? Very simple. So just write 2 to power 0, 2 to power 1, 2 to power 2, and 2 to power 3. So wherever 1 is there, 1 is what? 2 to power 0. Then you can simply write here 1, rest will be 0. Similarly here 2 is there, right? So here 2 to power 1 is 2, rest 0. So one binary representation is 0, 1. 2's binary representation is 1, 0. Similarly 3 is how? 2 plus 1. So this is 2 to power 1. So 2 plus 1. So 2 power 1, that is 1. This is 1, right? Rest 0. This is the binary representation of 3, right? And finally 4 is 2 square, right? So it will be 1, rest will be 0. This is the binary representation of 4. And this way you will be having binary representation of each of the number. But you don't need to worry about that. You don't need to remember actually, right? So this is used in a very low level programming language whenever you are working with the machine level code. So you don't need to worry about that, right? This will be used by mostly the people working in semiconductor industry, right? This type of operations are majorly used there. But let's try to look at this. So for example here, so we have again bitwise operations at bit level. So let's say we have some value, let's say 2 and 3. What will be the value? So 2 and 3, it gives you 2. But now if you want to know what is the binary value of 2, so just write binary value of 2. So it will give you the binary value, that is 2, and let's say binary value of 3, it will give you 3, right? So 1, 0, 1, 1. So already you know this is your AND operation, this is your bitwise AND operator. So what happens Here try to understand, we have already seen this. So 1 0, and is there 1 and 1. So and means if both is true then only true, otherwise false. So here it is 0, 1 and 1 is 1. Again this is the binary representation of 2, and that's why you get 2. So 2 3, 2 and 3, right, you get 1 0 again, and then again 1 0 is a binary representation of 2. This is the way you understand. Now you guys can try multiple things. So for example, let's say 10 and 12. Now 10 and 12 comes 8, so you can just check binary of 10, right, then you can check binary of 12, right, binary of 12, and then finally you can also see binary of 8. You can compare with AND operator. You will find that if you do AND here with these two values, you will get this. Similarly OR, so let's say here OR, bitwise OR looks like this, 3 or 4, you will get some value like this. Do binary of 3, and then right, binary of 4, right, and if you just do the calculation the way we did AND operator, it will give you the result of binary of 7. That's the understanding. We have also negation. So this will give you, negation is written like this. This is a symbol called tilde. It will give you 1 less than whatever value you have with a negative symbol. Tilde 3 is minus 4. So let's say you have tilde 100. So tilde 100, it will give you minus 101. This is the understanding. Then we have bitwise XOR operator. Bitwise XOR. Right. What is the XOR operator? Already you might be knowing, many of you, what is XOR? Exactly, right. One operand is 1. Right. So here A and B. Let's say 0, right, 0. Right. I'll just write it like in a good way. The writing is not good, so I'll just write it in a good way. So here let's say XOR. Many of the people will say JOR, but let's say XOR. So exactly one operand is 1. So how to look at this? A or B, right? So 0 or 0, it will be 0. 1, right, and then 0, it will be 1. 0 1, it will be 1, and again 1 1 0. So wherever, right, exact 1 is there, exactly one operand. So this is operand, A is operand, B is operand, and this is called as operator. Operator. So that will be 1, rest will be 0. This is the understanding of XOR, right? So now moving ahead, this is your bitwise XOR. So now let's say 5 XOR 6, right? You will get 3. Now you can just check it out. Bin of 5, and then bin of 6, right, and then finally bin of 3, right? You will just, when you will do XOR between 1 0 1 and 1 1 0, so exactly 1. So this, see, 1 is there, and then 0 1, again 1 is there, rest it will be 0. That's how you got 3, and that's how the result is 3 also. So you just need to compare now. That's it, right? Now moving ahead to last 2 operator, that is shift operator, and shift operator is of 2 types. So this comes under bitwise operator. So left shift and right shift, and this is very easy actually. Left shift and right shift. So what is left shift? Put the number of zeros on the right side. Put the number of zeros on the right side. Done. Right. For example, I will show you. So 25, let's say 25 is there, and then this, right? This is called as right shift, right? So take any number. So let's say 24 shift 3, right? So now if you see, the value is 192. Now how to understand this? So bin of 24, just do bin of 24. So you will get this value. Now what we have to do? Put 3 zeros on the right side, 1, 2, 3, and this should be this particular number, or the binary representation of 1 and 2 should be this particular number. Let's check it out. So now what I will do, right? Very simple. Just write bin of 192. See here, same thing, 111, sorry, 11 and 360. See here, 360, right? So this is your left shift operator. Similarly, you can also compare any other values. Let's say 8, right? 8 shift something like this, 2. Just you need to do bin of 8 and bin of 2 and just compare this, right? Now comes right shift operator. This was your left shift. Now right shift operator, right? So what is right shift operator? Again, remove the number of elements in the binary. What is the meaning of this? So let's look at this. So example 200, and then this is your right shift operator, right? So this is your right shift operator. So we have seen left shift. So here we were put the number of zeros on the right side, but here you have to remove the number of elements. So let's say 3 is there, 200 right shift 3. So just do bin of 200. So bin of 200. Now if you see, these are the values, right? Now once you do bin of right 25, then you will realize that these 3 zeros are not there. So let's do it, bin of 25. So once you do bin of 25, you will find only 11001. See, 11001. So this is the understanding. This was all about operators. Now one more thing, order of execution. How the code is executed in the Python execution. Now you might have heard about board mass rule in your school days, right? Similarly, here are also some rules, right? So always the code will execute from the left. Code will execute from left. There are some exceptions. I will talk about that. But let's say here 3 plus 2. Let's say 3 plus 2. That is minus 4, for example. So here you will get value 1. So first 3 plus 2, 5, then minus 4. So let's say another value. Let's say 10 plus 1, right? And then plus 7 divided by 3. So it will give you this value. First it will calculate this, then it will calculate this, and then do the addition. So there is a whole complete table of order of execution, but you don't need to remember this. So order of execution in Python, right? So there will be some image. So I'll just go to a random image. I'm not sure which image should I go. This is also called as order of precedence, right? Copy image, right? So here order of execution or precedence, right? So I'll just copy paste it for the notes, right? So you guys can access in the notes as well. So this is the way everything, this is the priority. So highest priority top one, and then we have the lowest priority and so on, right? So this priority like this, right? But you don't need to actually memorize anything, right? This will, always you can just see or execute the code and just check it out. So you don't need to memorize this. So this would be all for this lecture. If I have to summarize everything, and also we'll be talking about the interview question. So if I have to summarize everything, right? So we started with different way of representation of variable. So summarization. So I'll talk about the summary now, and then I will end this video. Summary. different way of declaring the variables. First, second, we started with comments, single line comments, multi-line comments. Then we took input from the user, then we saw typecasting, right? We discussed typecasting in detail. Then we saw concept of mutability, and then finally we also saw operators, right? So everything we saw in detail, and this should be your one-stop solution for all the things till now in Python, right? So this is the understanding. Now interview questions for all of these topics, right? If I talk about interview questions, right? So for these topics, right, what is mutability? Very important concept, right? Which data structures are mutable? Obviously which data structures are mutable, you will be getting this answer at a later stage, but as of now you can just say that list is mutable. So what is mutability? Mutability in Python, this is very important. What is operator? Right? Obviously in operator I have discussed every use cases, but you don't need to remember any specific use cases. It will come with practice. Bitwise operator rarely you will use, but I have already mentioned this is widely used in embedded. Yes, membership operator is very important. They can ask you questions in what is a membership operator and something like that, right? So these are the two questions that is important. See, operator is a very vast topic, so we have covered it completely. So what is the use case of membership operator? What is the use case of logical operator? So those type of questions can be asked. Now one more question that I usually give you guys to explore, right? Extra mile or food for thought, right? How variable is stored? This is something I have not explained till now, and this most probably I will be explaining in data structure chapter, how variable is stored in a memory. You have to understand the memory management of Python. So how variable is stored? So this is something you need to understand, or you should explore on your own, right? Now in the details I will be putting the Jupyter Notebook, this PDF. You guys can go ahead and explore it, try to revise. Always remember, if you have reached till this part and you haven't understood a lot of things, then only thing I would suggest, please type the code while seeing the video. I am 100% sure you will understand this. And if you really like my teaching style, like the way I teach in with examples, or you want to understand things in depth, then we have our flagship program, that is advanced certification program in data science and artificial intelligence. You can go ahead and see the description of the video to know more about it. That would be all for this video. Thank you everyone. Bye bye.